And welcome back to the next session of Ricky's Math Minute. The next video in this series is continuing our first one, which is 16 must-know ACT math formulas. In this video, we are going to break down how to use some of them. Specifically in the pre-algebra round, we're going to look at average, probability, and quadratic formula, and we're going to be using these to do so. So first, let's look at average. Adam tried to compute the average of his 7 test scores. He mistakenly divided the correct sum of all of his test scores by 7, which yielded 84. What is Adam's correct average test score? So let's look at this. We have the total, whoa, that's not right. We have the total of all of his test scores over the total number of tests that he took equals his average. Well, we do not know the total of his test scores. And we know that when we divided that total by 6, we got 84. So now we need to find how to get 7. Well, if we multiply both sides by 6, that's going to give us our total number, or our total sum of test scores, which is 504. Well, then we can take 504 and divide it by 7 to arrive at our average, which is 72. So no sum needed here, just a simple, straightforward problem that you have to take a second to read to realize exactly how to set it up. We knew that when we divided our sum by 6, we got 84. So we needed to find the sum first. And that's what we did to get 504. All right, so now we have 35 juniors getting a score of 80, an average score of 80, and 15 seniors getting an average score of 70. What was the average for all 50 students? We know that we have a total of 50 students, but what we don't know is what their total scores were. So how do we find that? Well, we know that some number divided by 35 gives us 80, and we know some other number divided by 15 gives us 70. If we get those two numbers, then we can add them together, kind of like what we did in the first one. So multiply by 35, multiply by 35, 15. You're going to get x equals 2,800 and y equals 1050. When you add those together, you're going to arrive at 3,850. Boom. Well, what do we do now? Well, you just simply divide out, and you're going to get that all 50 students had an average of 77. As we move on, we're getting ready to look at a couple of probability problems. If you find yourself struggling with problems like this and would like to see some more examples, just reach out. We can put together a video for you. All right. What is the probability that a number selected at random from the set 2, 3, 7, 12, 15, 22, 72, and 108 will be divisible by both 2 and 3? Well, what does it mean to be divisible by 2? Well, divisible by 2 ends in an even number. Okay, any even number. Well, what are our even numbers? 2, 4, 6, 8, and 0 are even numbers. If it ends in any of those, it's divisible by 2. All right. What does it mean to be divisible by 3? Well, divisible by 3 is the sum of the digits is divisible by 3. An example of this is going to be 102, right? Well, 1 plus 0 plus 2 is 3. 3 can be divided by 3. Therefore, 102 is divisible by 3. So now let's look. 2, 12, 22, 72, and 108 are all divisible by 2. 3, 12, 15, 72, and 108 are all divisible by 3. Well, the question asks, what's the probability that a number selected will be both 2 and 3? Have divisibility both 2 and 3. Well, look at the ones that have lines on top and bottom. 12, 72, and 108. Well, we know based on this that probability is our target outcome divided by total outcomes. Well, what are our total outcomes? Well, there's 8 of them. And then how many numbers do we have divisible by 3 and 2? Well, 1, 2, and 3. So 3/8. No real math required there, but what was required is that you know the divisibility rules of both 2 and 3. So it might be a good time to brush up on what it means to be divisible by certain numbers and how to find that. Okay, Jacob was 27 years old when his son Mike was born. Mike was 23 years old when his son Sam was born. Sam will celebrate his 7th birthday in 2014. What year was Jacob born? Well, we don't know what year Sam was born, but we know that his 7th birthday is in 2014. We know that Mike was 23 when Sam was born, and we know Jacob was 27 when Mike was born. Well, and we know also that Sam's 7th birthday is in 2014. So we have Jacob, it's 27. Mike is 23. And Sam is 7, but we know 24 minus 7 is going to give us Sam's birth year, which will allow us to go backwards. So really what you have to do is we start at 2014 and we minus Sam's age. That's going to get us to 2007. From 2007, we know Mike was 23 years old, so we need to subtract 23. And we arrive at 1984. Well, in 1984, when Mike was born, we know Jacob was 27. So we subtract 27, and we arrive at 1957, which would be the year Jacob was born. This question is a little different because it was under the probability section, but you're not really finding the probability in this particular problem. But still an interesting problem because you're having to work backwards. So definitely remember kind of your approach for this. Okay. What is the probability of choosing 2 consecutive red cards from a standard deck of cards if replacement is not allowed? Some key things here. Replacement, not allowed, which means when we take a card out, we cannot put it back. 2 consecutive red cards, 2 red cards back to back, and it's a standard deck. Well, probability deals with decks of cards often or dice. How many cards are in a standard deck? Well, you have 52 cards in a standard deck. How many of those cards are red? We have 4 suits. 2 of those suits are red, 13 and 13. So you're going to have 26. Half of your cards are red. Well, remember, target number divided by the total outcome. So I know when I draw a card, I have 26 chances of getting a red one the first time. I know when I draw a card again, I only have 25 chances. Why? Because replacement is not allowed. So I automatically, if I get that red card first, the second time, I have 1 less red card to draw from. Well, I start with 52, and then I have 51, because again, replacement is not allowed. You multiply those 2 together, and you arrive at 650 over 2652. And that's your probability. Of course, that's not going to be an option because simplifying is probably going to be required. If you divide both of those by 26, you'll arrive at 25 over 102. And that would be your probability of drawing 2 consecutive red cards. It would not be 2 out of 52, okay? Which could be a common mistake that people make when they think probability, because they're like, well, I can get 2 cards out of 52, but you got to take into account every possible solution, which is why you arrive at such a large number. And now we're going to round out this quick session with 3 using the quadratic formula. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, what do these variables mean? Well, a quadratic polynomial is going to be in the form of ax squared plus bx plus c equals 0. Some important things to note. They're both positive. A is going to be your coefficient with your x squared. B is going to be your coefficient with your x. And C is going to be your constant, okay? Every time. Even if it's in a different order, this A is always with your x squared, all right? I would recommend writing it in this order as you're solving these problems. So let's look at this first one, okay? We have, using the quadratic formula, we need to find our roots or our factors, right? And it says which of the following because this would be a multiple choice question. But we have negative b first. Well, if it's negative b, this is already a negative 3. What negative b means is opposite, okay? So we need the opposite of negative 3. Well, the opposite of negative 3 is going to be positive 3 plus or minus negative 3 squared. What happens when you square a negative? It becomes positive, so keep that in mind. A and C, but remember C is positive here. So that means we have to match this sign. So we're actually multiplying by negative 5. If you forget to do that, you're going to get a negative square root, and then you're going to get into imaginary numbers and complex numbers, and we're obviously not dealing with that in a 1-minute math question. So all over 2 times 2. What you get is going to be 3 plus or minus the square root of 49, eliminating some math there, over 4, which is going to be 3 plus 7 over 4, or 3 minus 7 over 4. So you get negative 1, 4, 5 halves. Now, what you should be able to do with this is our quadratic expressions, our polynomials are always set to 0. So you should be able to substitute both of these in here for x. So, 5 halves and then 5 halves, and then negative 1 and negative 1, and you should get 0 if you've done the work correctly. In this case, you will. I won't take time to complete that substitution. Now, sometimes you're given a polynomial that doesn't have a leading coefficient. What that means is a is 1, and sometimes that makes it really easy, especially when you're dealing with 2. All right, so what are the factors of 2? Well, the factors of 2, well, 2 times 1. Those are your only factors. So we know x squared breaks down to x and x as a binomial because x times x is x squared. Well, how do we get 3 if we use FOIL method? Well, x plus 2 and x plus 1, these are still equal to 0. So you set this apart, x plus 2 equals 0, x plus 1 equals 0, x equals negative 1, or x equals negative 2. Again, you substitute these in here, you're going to arrive at 0. But more importantly, you can do that problem rather simply just by understanding how to FOIL binomials and knowing what the factors of your constant are. If you can't look at this and see it this way, you can always default back to this. Will we arrive at the same answer if we do it that way? Well, of course we will. Negative 3, because again, it's the opposite of b, plus or minus 3 squared. 4a, c is 2. all over 2 times a, which is just 1, equals -3 plus or minus 9 minus 8, which is going to be 1, all over 2. Well, what is the square root of 1? The square root of 1 is 1, so -3 plus 1, or -3 minus 1, 2. So this is going to be -2. I've done something wrong. -2 divided by 2. So -2 divided by 2 equals -1. And -4 divided by 2 will equal 2. -2, sorry. So that'll still give you your same roots. So either way, obviously, if you can look at it this way, makes your work a little bit more straightforward, but you can use quadratic formula for any um, polynomial like this. All right. My equation disappeared. So in this last one, we are working with 3x squared minus 16x minus 12 equals 0. X equals -b plus or minus a c all over 2 times 3. You're going to get 16 plus or minus the square root of 400 all over 6. 16 plus 20 over 6, or 16 minus 20 over 6. So you will get roots of 6 or -2/3. Again, you can substitute these in to your original equation and arrive at the answer. This is a very condensed, very quick version of these problems. These are things that teachers take an entire unit to instruct. This was a quick math minute. If you are still foggy on quadratic formulas, probability, average, and you want to see more, send me a message and let me know. If not, and you want to see something else, let me know. Otherwise, in next week's video, we're going to continue and look at some intermediate algebra and some more formulas that are must known for your ACT math test. Thank you all for tuning in. I'll see you soon.